Don't forget to like and subscribe for more videos. Also, there might be corrections in the description, and the soundtrack of this video is there as well. Explosions are cool, but what is an explosion, and what was the biggest? To be more clear, I'm referring to the largest non-nuclear human-caused explosions, so supernovas, volcanoes, atomic bombs, and asteroid impacts don't count. What is an explosive anyway? Take for example RDX, a stable secondary high explosive. When hit by an incredibly powerful compressive force from a primary explosive like lead azide, it decomposes explosively. This reaction forms nitrogen oxides, which are more stable than RDX, therefore releasing energy. Since the explosive has been converted to a superheated gas at around 5,000 degrees Fahrenheit, it expands rapidly. This causes a chain reaction traveling many times faster than a bullet, leading to a powerful explosion. This is known as a detonation. Another type of explosion is a deflagration, which is slower than the speed of sound, but they can still be dangerous. Low explosives like fireworks burn, building up pressure, causing an exponential reaction until they explode. A BLEVE, or boiling liquid expanding vapor explosion, is another type of deflagration, caused by a high-pressure tank holding a gas like propane violently rupturing. The resulting fireball causes destruction and emits a powerful wave of thermal radiation that can cause burns from a distance. Speaking of BLEVEs, the date is June 21st, 2019. The location, the alkylation unit of Philadelphia Energy Solutions. An alkylation unit combines a gas called isobutane with gases like propylene or ethylene under an acid catalyst like highly toxic and corrosive hydrofluoric acid. This produces alkylate, which is used in gasoline. A heavily corroded propane pipe ruptured and a ground-hugging vapor cloud formed. About 2 minutes later, the propane cloud ignited and fire roared out of the pipe like a torch, heating a large tank full of isobutane. At 4:22 a.m., the large tank full of hydrocarbons exploded in a massive BLEVE, launching the 20-ton tank fragment half a mile away. The tank was holding over 350 tons of butane. BLEVEs are intense enough to burn people thousands of feet away, and accounts say the explosion illuminated the night sky for miles away. It's hard to estimate exactly how powerful the explosion was, but it's probably around 250 tons of TNT equivalent. After the blast, a fire burned until the next day. The explosion caused the company to go bankrupt and almost caused a large hydrogen fluoride release had it not been for swift action, moving the acid to a safe storage tank. A worker also had to manually enable HF mitigation water cannons that malfunctioned. Also worth noting is that a few drops of HF or hydrofluoric acid on skin can be rapidly fatal. What about larger explosions? 6th of February 1955, Operation Sailor Hat shot Bravo. A 10-meter wide dome of trinitrotoluene sits poised upon a Hawaiian beach, ready to release nearly 2 trillion joules of energy. Smoke rockets launch. Hold up, why is there 500 tons of TNT on a beach? In 1963, the Nuclear Test Ban Treaty was signed by the U.S., Soviet Union, and Great Britain. The treaty banned underwater, atmospheric, and nuclear testing. The U.S. had to find alternative ways of testing nuclear damage. Okay, resume. In an instant, the sphere is heated to thousands of degrees and a fireball expands to many times the size of the dome. The fireball expands at almost 20 times the speed of sound, so rapidly that air doesn't have time to move aside, forming a devastating pressure wave of over 10 psi. To put that in perspective, a 1 square meter panel would experience nearly 8 tons of force. The destructive pressure wave races towards the 3 test ships present, the USS Atlanta, the USS Cochrane, and the HMS Fraser. The blast force blows in walls and obliterates radar equipment, and shrapnel is thrown half a mile. The plume rises as high as the surrounding clouds. Reports say the cloud was visible for more than 50 miles away. Next explosion. NH4NO3, ammonium nitrate, a widely used fertilizer mass-produced in quantities of several thousand tons. Ammonium nitrate is very stable on its own. You can hit it with a hammer, shoot it, light it on fire, even blow it up, and it probably won't explode. But if it's stored in a confined space like Warehouse 12 of Beirut with an intense fire, well, it's a different story. A fire finds an ignition source, possibly from the fireworks. The fire spreads to a big pile of tires. After around 10 minutes, firefighters arrive. Then 13 minutes later, the whole warehouse is obliterated by a devastating explosion. One of the most striking features of the explosion is the massive spherical condensation cloud. The shock wave caused by the explosion compresses the air, causing clouds to be spontaneously created and destroyed. This only happens in very humid regions like beaches. The shock wave swept across the city to devastating effect. The explosion had a yield of nearly 1,000 tons, or 2 sailor hat explosions. One of the most dangerous aspects of explosions is shrapnel. Imagine that you're watching a building fire, and all of a sudden you see a large vapor cloud. Then seconds later, bang, the window is blown in with enough force to launch glass shards directly at your face. These projectiles can cause cuts or eye injury, and the shockwaves can cause concussions and eardrum rupture. Nitrogen oxides can cause lung irritation and can lead to asthma. Next explosion. White Sands Missile Testing Range. Minor scale. 17 trillion joules. 4,000 tons of TNT. Nearly 4 times the yield of Beirut. Using ammonium nitrate, this time mixed with diesel to form an explosive known as ANFO. Boom! The shockwave races out in all directions. Nearly 5 minutes later, devices used to measure the ionosphere detect changes in reflectivity. What's so impressive is that there's almost no air 100 kilometers up. A shockwave warps the air effortlessly, and a cloud rises miles above the scene. You can see the shockwave traveling at about 1,000 miles an hour, appearing to move slowly. Rock fragments are launched miles. And there you have it, the largest non-nuclear human-caused explosion ever. To quote the Minor Scale Test Execution Report, question, why is minor scale larger than direct course? Will future tests continue to get bigger? A. Minor scale was planned to simulate the battlefield environment. Future tests are not projected to get bigger than minor scale. And to this day it holds true. But it's time for some honorable mentions. The Halifax explosion was the largest non-nuclear accidental explosion at 3.9 kilotons. 2 boats collided, leading to a massive explosion damaging the town of Halifax, Nova Scotia. Shoemaker Levy 9, which deserves a whole video, is the largest explosion that happened while at least a few people watching this video were alive. It was a comet, more specifically Fragment G of the SL9 comet. It impacted Jupiter with a force of 6 billion kilotons. The largest ever explosion was likely a pair instability supernova. They happen when gamma radiation in a star is so intense it creates antimatter, leading to a drop in the pressure of the star. This heats the core, leading to even more antimatter production, dropping the pressure more. The star collapses more and more until the star detonates with the power of a thermonuclear bomb around 250 times the size of the Sun. No black hole is left behind as the star explodes before fully collapsing. Well, thanks for watching, and don't forget to like and subscribe as it greatly helps the channel. And no, the Big Bang wasn't an explosion.